All right, let's do an example. Civil War, a movie, a civil action, tells the story of a major legal battle that took place in a small town of Woburn, Massachusetts. The town well that supplies water to East Woburn residents was contaminated by industrial chemicals. During the period that residents drank water from this well, a sample of 414 births showed 16 birth defects. On the west side of Woburn, a sample of 228 babies born during the same time period revealed 3 with birth defects. Is there evidence that birth defects are significantly higher in East Woburn? Well, uh, currently, uh, Flint, Michigan has the same problem. Uh, but let's look back at this one. So our null hypothesis is that the proportions of birth defects is the same. And instead of using P1 and P2, it's probably going to be better if I talk about east and west. So let's say probability of east is the same as the probability of west. And now we want to see if we have evidence to see that uh, they're higher in East Woburn. So we want to find the probability that in East Woburn there's more proportion of birth defects as in West. So I'm going to uh, write this out. P subscript E means that it's the proportion of um, birth defects in East Woburn, whereas PW, all we have to do is take out the E, turn that to a W, subscript it, and then we say that we're dealing with West Woburn. So we have to define both variables here. Great. Now we look at conditions. Did the data come from a random sample? Can't say that, so we are not sure if the data come. All right. Now we need to check normality. For normality, we need to check that n times p and n times 1 minus p is greater than 10. Now we got to think about what our p is. Well, let's find our combined p. We talked about it, but we didn't actually find anything. So a combined p is taking the values 16 plus 3 over our total, which is 228 plus 414. So that's going to be 19 over, what's that, 642. So our combined P is 19 over 642, which gets us about 0.2029 or 0.03. So that's what we use for our values. So we need to make sure our sample of both of these multiplied by there are going to be greater than 10. So is 414 times 0.03, that gets us 12.25. That's greater than 10. Now if we multiply it by 228, I have a bad feeling about this. It's only 6.612, which is not greater than 10. So normality is a little bit in question. With two sample tests, they're a little bit more robust than one sample test, but for this particular case, we can say we proceed with caution. Um, Now for independence, uh, I would just assume that each birth is independent. All right, we got that out of the way. So now we go to the calculations. So for calculations, what we need to do is uh, find our z-score. So I'll switch to my pen. So our z-score, what we do is we take one p hat minus the other p hat. So let's find our values. We have p hat 1 and p hat 2. All right, and our p hats are, our first p hat is 0.0386, and the other one is 0.013215. All right, so those are our p hats. So now we take those down here and we subtract those p hats. So I have 0.0386 minus 0.0132, all divided by our standard error. Now our standard error, we take the square root of our combined p, which is 0.03, times 1 minus 0.03, which is 0.97, multiplied by 1 over n1 plus 1 over n2. So we're going to multiply this by 1 over 414 plus 1 over 228. Now one thing to remember, one thing that I typically forget, is we have to name the type of test that we're doing here. So we call this a two proportion z-test. All right, now we want to find the value for z. All right, I plug that into my calculator. I got a z-score of 1.823. So we want to find the probability that our z is greater than that. And I got a value of 0.034. So now we just have to talk about what this means. We reject our null hypothesis because our p-value of 0.0334 is below our alpha level of 0.05. So we have evidence that that East Woburn has a higher birth defect rate than West Woburn. All right, hopefully that makes sense. Good luck.